Welcome to the YouTube channel PCMB Tutorials. I hope you all are fine. Today we are going to learn class 9th chemistry chapter types of chemical reactions and energetics part 9. So in this part we are going to learn Faraday's laws of electrolysis. Let us start with it. The relation between the quantity of electric charge passed through an electrolyte and the amount of substance deposited at the electrodes was presented by Faraday in 1834 in the form of laws of electrolysis. 1834. Now our topic is Faraday's first law of electrolysis. Faraday's first law of electrolysis. The amount of a substance produced during electrolysis is directly proportional to the quantity of electricity passed through the electrolyte. Mass of the substance deposited is directly proportional to quantity of the electricity passed. But the quantity of the electricity is the product of current passed in amperes and the time in seconds for which it is passed. Q is equal to I into T. When the current of 1 ampere is passed for the period of 1 second, the electricity passed is called 1 coulomb. 1 coulomb is equal to 1 ampere into 1 second. Now we get M directly proportional to I into T. Finally, M we got equal to Z into I into T. Z is the electrochemical equivalent. Electrochemical equivalent is defined as the mass of the element produced during electrolysis by passing 1 coulomb of electricity. Unit for Z is equal to grams per coulomb. Let us solve a question based on it. A current of 16 ampere was passed through an electrolytic cell containing molten NaCl for a period of 100.5 minutes. How many coulombs are used up? How many grams of sodium metal were obtained? So given is current I is equal to 16 amperes. Coulombs used up is equal to ampere into time in second, that is Q is equal to I into T. So we get Q is equal to 16 into time 100.5. We'll convert it to fraction and we will get 96480 coulombs. When 96,500 500 coulomb of and electricity is passed, then the amount of metal obtained is 23 gram. When 1 coulomb of electricity is passed, Mn metal obtained is equal to 23 upon 96480 gram. When 96500. When 96480 coulomb of electricity is passed, and the metal obtained is equal to 23 upon 96500 into 96480. The answer we'll get is 22.99 grams. Thus 22.99 gram of sodium metal will be obtained. I hope you have understood till this. Next topic is Faraday's second law of electrolysis. So I'll draw a diagram. These are the beakers. First beaker is filled with CuSO4 electric cell. These are the electric cell. Now this is AgNO3, and over here it is 2H2 H2SO4 electrolytic cell. This positive charge is connected to a battery. With this positive terminal, this negative terminal, this positive terminal, this negative terminal, this positive terminal, and this negative terminal. When the same amount of current is passed through the three voltameters containing CuSO4, AgNO3, and H2SO4, we observe that the amount of copper, silver deposited and hydrogen liberated are 107.9 gram, 31.77 gram, and 2 gram respectively. Inference: when the same amount of current is passed through different electrolytes, then the masses of substances deposited or liberated are in the ratio of their equivalent masses. Law: when the same amount of charge is passed through different electrolytes, then the masses of different substances deposited at the respective electrodes will be in the ratio of their equivalent masses. To deposit 1 gram equivalent weight of any substance, 1 Faraday, that is 96,500 coulombs, is required. Faraday. Now Faraday is the quantity of the electricity passed by 1 mole of electrons, that is 6.023 into 10 raised to 23 electrons, and is equal to 96500 coulombs. The number of Faradays required to discharge 1 mole of an ion during electrolysis is equal to the number of charges on that ion. 1 mole of singly charged ions require 1 Faraday to get discharged. 1 mole of double charged ions require 2 Faradays to get discharged. 1 mole of triply charged ions required 3 Faradays to get charged. Now there are some questions based on this topic which we will see in part 10. Question based on Faraday's second law. Then applications of electrolysis. Then we will see metallurgy electroplating, how to obtain a smooth and firm deposit of a supermetal in electroplating an article with silver. I hope you've understood till this. The other remaining details of this chapter we'll see in part 10. Thank you for watching.